Every week, the LIGO detector captures gravitational waves emanating from collisions between black holes and neutron stars millions of light years away. Quite recently, a team of astronomers has used it in their attempt to catch, in theory, subtle LIGO mechanisms can be sensitive to invisible light emitted by such photons. However, no actual traces of these particles have been found yet. Searching for dark matter isn't only a scientific challenge, as according to one of the new models of the universe, this strange substance could devour ordinary matter until there's not a single star left throughout the entire cosmos. In this video, you'll find out, how does dark matter warp galaxies? Can there be swarms of giant black holes lurking in the vast reaches of space? And most importantly, why is dark matter dangerous to us? Scientists are observing the universe and waiting for data links from dark photons. Then scientists can collect dark photons' personal data and send probes to them for research. But data breaches in space and in ordinary life are different things. Just imagine, you subscribe to the NASA newsletter, but receive thousands of messages in your spam folder. NASA rarely suffers data breaches, but for data brokers who collect and sell your personal information, it's a common thing. Luckily, you can protect yourself with Incogni. The service will identify a list of brokers who may have your data and request your personal information to be removed from their databases. It would take you years to do it manually, but Incogni's algorithms know how to automatically send requests, deal with objections, and ensure your data doesn't end up in the wrong hands again. Click on the link in the description, sign up on Incogni, and the first 100 people who use the code RIDDLE will get 20% off on an Incogni subscription. In the meantime, I'll reveal to you some personal data about the dark matter. But wait a second, what's made us think that outer space is full of some weird invisible substance in the first place? American astrophysicist Fritz Zwicky was far from these fantastic ideas in 1933. However, the longer he kept observing a cluster of more than 1,000 galaxies in the constellation of Coma Berenices, the more he realized that something very odd was going on there. In that place, galaxies move as if they're 400 times heavier than the stars and gas they're composed of. It seems as if the cluster is enveloped in a transparent cloud of what Zwicky called dark matter. Astrophysicists later saw that many galaxies rotate too fast, and if there were no external constraints, they would have stretched out their spiral arms all over the universe. The answer to this mystery lies in massive dark matter halos. Now, if you need some more tangible proof of its existence, check this footage. It looks like a space gallery of crooked mirrors. Some images of galaxies are greatly distorted. The others resemble multiplied reflections. All of these phantoms are products of dark matter. Its invisible mass creates the gravitational lensing effect when everything in close proximity gets deformed. Astronomers have found hundreds of these dark lenses across the skies. Eventually, modern calculations show that just 15% of our universe is ordinary matter, and 85% of it is dark matter. This ubiquitous loose material has much in common with sofa stuffing, although some scientists are convinced that, despite all these facts, dark matter is a pure illusion. Why is there a possibility that dark matter doesn't exist at all? In 1983, Mordechai Milgram, an astrophysicist from Israel, became the first to offer a good alternative to dark matter. He called his theory MOND, for Modified Newtonian Dynamics. Milgram thought, what if gravity works differently at different spatial scales? This means that planets move along their orbits the way we already know. But when it comes to galaxies and clusters, gravitational influence dramatically changes. It's one thing to throw a paper plane in your backyard. It's quite another to pilot an airliner across oceans. The forces that set them in motion are different in these cases. When MOND appeared, people stopped using dark matter to explain why galactic disks rotate at high speeds, or why galaxies and clusters interact the way they do. Milgram's theory copes with the task much better. As for the interaction of galactic clusters, the scientists introduced the notion of the external field effect. It means that, on the scale of millions of light years, huge masses have a very special effect on each other. I'll be more specific. The paper plane you throw down at the ground could just as well get caught up in the wind created at high altitude by an airborne jet. Does this mean that dark matter is now defeated and forgotten? Unfortunately, MOND can't explain where countless gravitational lenses come from. What's more, Milgram's theory is clueless about the reasons behind many galactic collisions, and that brings us back to the idea that we still need some additional invisible mass. But why have we never found any particular objects consisting of dark matter or its particles? Some scientists are still resolute about finding ordinary matter hidden in undetectable forms. Let's talk about MACHOs. No, that's not a new famous boy band. It's an abbreviation for Massive Astrophysical Compact Halo Objects. It includes neutron stars, brown dwarfs, intergalactic gas clouds. In short, all massive objects that our telescopes can't detect for whatever reasons. Here's the trouble though. According to all calculations, there's no way the Big Bang could produce 5 times more matter than we can see. So MACHOs go straight to the place where the Backstreet Boys now live: history books. Theorists then invented WIMPs. I know, it reminds you of the animated series about fairies, but in fact, that means weakly interacting massive particles. They don't react to ordinary particles of matter, but can produce all observed gravitational effects of dark matter. Astrophysicists have spent ages trying to find gamma-ray bursts caused by WIMPs during collisions, and hopefully at least the slightest trace of their interactions with ordinary matter. They've used special crystal detectors cooled to only a few degrees above absolute zero, and other sophisticated devices. But despite so much effort, years of searching have brought no results. It looks like WIMPs are just another fantasy. There are other hypothetical and very light dark matter particles called axions, and these guys look more promising. Yes, this time you've got it right. Physicists have given them a name that clearly refers to the famous dishwashing liquid. Axions explain all the dark matter effects, and there could have been a great deal of them right after the Big Bang. So, where are they? In 2020, with the help of the Xenon 1T detector filled with more than 3 tons of liquefied xenon, scientists spotted a bit more particle interactions than they'd expected. Axions were the first thing that crossed their minds, but nobody was sure. They need to run further tests to confirm their suspicions. But hold on, aren't we forgetting other hypotheses about dark matter? Some of its forms could be very dangerous. Why could dark matter pose a threat to all of humankind? Imagine a giant black hole. No, not the one that stars leave behind, and even not that supermassive monster from the galaxy's center. Something in between. Yes, this is a primordial black hole with an intermediate mass of around 30 suns. It was born together with the universe out of whirling energies generated by the Big Bang. There were neither stars nor disks of hot glowing gas that could help us notice it. A primordial black hole like this is surrounded by hundreds and thousands of its own twins, and together they form dark clusters. They may be lurking right behind the edge of our galactic disk, and we'll never see them unless this swarm of black holes attacks the solar system, gobbling up everything they meet on the way. Bad news for us, but a very credible hypothesis. Well, at least that part about dark matter. And this isn't the worst-case scenario. Not yet. At the end of 2021, an international scientific team led by Norwegian professor Torsten Bringmann released quite a dismal picture of the universe. According to their theory, the Big Bang produced very few dark matter particles. As time passed, they started to rapidly multiply and devour everything they're able to reach. Particles of this carnivorous dark matter convert particles of ordinary matter into predators as well. This process develops exponentially, meaning that this substance swallows up more and more ordinary matter over time. And that's why there's so little left of it now, only 15%. Sooner or later, the dark cloud may run into Earth and literally consume it. There's no strong bonding between dark matter particles, so our planet will simply crumble, as well as all the stars in the universe. However, there's one last possibility. Perhaps there's indeed no dark matter in outer space at all. Perhaps there's an entire parallel universe instead. Physicists have called it Hidden Valley. This is a universe entirely made of dark matter that lies close to our own in another dimension. The mass of Hidden Valley influences galaxies and creates gravitational lenses without ever being present in our universe. That's like a college party. The music's playing in your neighbor's room, but they blast it so loud the whole campus can actually hear it. Who knows, maybe if these two universes hit each other, a new Big Bang will occur. So tell me, would you like to start with a clean slate?